100 million years ago, in the time of the dinosaurs on Earth, a family of about 1,000 stars was born together out of a stellar nursery of gas and dust. Today, we call this star cluster the Pleiades, or Seven Sisters. Let's now go back in time to explore the lives of the Pleiades stars with the aid of this computer model. Everything in the universe is in motion. The stars in the Pleiades zip around at thousands of miles per hour. Over the past 100 million years, these stars have been busy, orbiting around the cluster, twirling with binary star companions, and encountering each other in an ongoing gravitational dance. But their positions in the cluster aren't the only things that change. So do their colors and sizes. You are watching the life cycle of stars. The most massive, bluer stars burn out most rapidly and die in dramatic supernovae explosions that can be as bright as billions of suns. As stars die, their skeletons are revealed. Exotic black holes, neutron stars, and white dwarfs are the dark remnants of once bright stars, depicted here with green whirlpools, magenta lighthouses, and cyan triangles. In death, most neutron stars and black holes are given a final kick, sometimes up to millions of miles per hour. These kicks rocket them out of the star cluster, across and even out of the galaxy. In a few billion years, some of these neutron stars and black holes could reach the Andromeda galaxy, a flight of 2.5 million light-years. The other stars and gas in our galaxy also affect the Pleiades. Their gravity tugs on the star cluster and strips away stars, producing beautiful tails and streams as the cluster spreads out across the galaxy and eventually dissolves. While inside a cluster, a star's life can be hazardous. Stars can come extremely close together. These strong stellar encounters are controlled by the force of gravity and can last for millions of years, sometimes swapping partners with binary stars, or perhaps leading to a direct collision and the merger of two stars, and often slingshotting a star out into space. This particular gravitational dance involves 8 stars. Strong stellar encounters, the pull from the galaxy, and the loss of mass as stars age all contribute to the evaporation of star clusters. The Pleiades is in the process of dissolving, just as our Sun's birth cluster did billions of years ago. Around the year 1910, astronomers Hertzsprung and Russell realized that we can gain great insight into stars' lives by plotting their temperature or color against their luminosity or brightness. Sorting these stars so that the brightest and hottest are on the top and left reveals a remarkably clean sequence. As stars age and run out of fuel in their core, they grow larger, brighter, cooler, and redder, moving upwards and toward the right in the diagram. The specific paths that stars take along this diagram trace their lives as they transition through fusion of different elements in different locations within the star. There are few plots in science that hold as much weight as this diagram. The foundation of much of modern astrophysics rests on this theory of stellar evolution. Matching real observations to the theory shown here provides one of the only methods for determining the ages of stars and the distances to them. The Pleiades in particular provides a crucial rung on the extragalactic distance ladder that enables us to measure distances across the universe. Humans have observed the Pleiades for thousands of years, yet this is only a tiny fraction of the lives of these stars. The next time you look up at the Pleiades, think of the dynamic and exciting lives that these stars have lived over the past 100 million years, and imagine where they are headed next.